SAT 22 for week 10. Let's take a look at our question here. In the XY plane, a circle has center C with coordinates h, comma k. Points A and B lie on the circle. Point A has coordinates h plus 1 plus k plus the square root of 102. And angle ABC is a right angle. What is the length of segment AB? How did we do on this question? Well, we answered 66.2% said answer choice A, which was the correct answer. Second place here, almost a quarter people chose answer choice B for some reason. Maybe we can get to the bottom of that. And how did we answer this? It was mostly by Desmos with, phoned a friend coming in second place there. So almost half. We got about 46% saying, hey, we used Desmos to get our answer. Pretty common here. And then we can see that we thought that this was a pretty tough question here, centered on 4. And let's take a look at the solution. All right, it has to do with a circle. It has to do with also right triangles, as we're going to see, Pythagorean theorem, distance formula, all of this stuff. Let's first sketch ourselves a picture. And sure, we could, put this thing right into Desmos if you wanted to. Do you want to? I do too. Okay, so we'll put this thing into Desmos with the H and the K. It'll handle this thing as, sliders. Yeah, all right, so here, let's zoom in here. I'm going to put in, first of all, the ordered pair H, comma, K. So, no, that's K. And H, and then comma, and then a K, right? And add sliders to those, and then it's just going to allow me to put a point anywhere in the coordinate plane here. Lovely. And then let's plot here, I'll even put the ordered pair with this thing. Oop. Right, and let's see, we'll put the new point here also, parentheses h plus 1. So that essentially just means it moves to the right of that center point, comma, and then k plus the square root of 102. So it goes up the square root of 102. So k plus square root of 102 there. And let's put that point on there. Okay, lovely. And then if I side by side this a little bit, we can just kind of move our point around. It's going to move the other point as well, right? And they're kind of locked into each other because of this plus 1. It should move this thing to the right one, and this plus square root of 102 is going to move this thing exactly up square root of 102. And there's supposed to be a circle that goes around the center point here, the red one, and it should intersect that purple one. And there is an equation for that. The problem is that you don't really know what the radius is, but we're going to do the work necessary to figure out that radius in a second. Here, to make this a little bit more obvious, what we're going to do is I'm going to make the h and the k exactly 0. 0, 0, the origin. All right, and that way I can see specifically what's happening here between these 2 points. I'm going to take a little snapshot of that guy. Smile. All right, and then let's import this thing. This is just so that we can get ourselves a little picture going on, and I can draw on that picture. Maybe a little bit bigger. There we go. And the reason why I wanted to do that, just to make it super obvious, the shape that we're dealing with here. So I want to find the distance between these 2 points right there. And on the coordinate plane, if we're moving diagonally, you can't just count up boxes. Instead, what you got to do is turn this thing into a right triangle. So I'm going to bring this segment straight down here, and then bring a segment straight across. There we go, we have ourselves a right triangle. And in this right triangle, I know this looks like this is 2 boxes, but it's not. Here's the number 2, this is 1. And it's going up, and I know it's 1 here also, right? We can see that that x coordinate there is 1, and it's going up 10.0995. That's the approximation of specifically the square root of 102. So here, I'll just put that on here so that you can see that specifically. The square root of 102, you can see there's that 10.0995 thing. been rounding off, right? So I'll just put this as the square root of 102, right? And then I could just use the Pythagorean theorem to find the length of the hypotenuse, and the length of the hypotenuse is going to be the radius of our circle. Okay, so I'll just do this right off to the side. I'll call it R. Why not? Call it R. So I have 1 squared plus the square root of 102 squared is equal to R squared. Right, and then that of course is 1 plus, and the square root and the square will cancel out, so 102 is equal to R squared. That makes 103 R squared, and then take the square root of that, and we get our R is equal to the square root of 103. So that's the length of our radius there. Now, if I wanted to see what this circle looked like that went through this, now I can basically put all of the pieces together, because here's what the equation of a circle looks like in general. So circle equation is more or less just the Pythagorean theorem. This is x minus h squared plus y minus k squared is equal to your radius squared. This is like your a squared. This is like your b squared, and then your r is like your c squared right there, right? It's the Pythagorean theorem. And I can go ahead and use the same h and k that we have here. So parentheses, double parentheses, x minus h, close them, square them, plus, made a parabola there for a second, y minus, and then k, and then square that guy, is equal to, and then here's where I'm going to put my radius squared. My radius is that thing that's on box number 5 there, the square root of 102, but I'm going to square it. The square and the square root are going to cancel out. No, one was not. Sorry. It was the square root of 103. But whenever I square it, r squared is going to be just 103, and that's the thing that's supposed to go here. And you're going to see as soon as I put this in, that circle is going to whip around the origin point here, and it's going to go through that purple point. Promise you, bam, exactly like that. Okay, and so now I can move this thing around everywhere, and I have my circle that goes through those points. Well, it goes through specifically that point h plus 1 comma k plus the square root of 102, but it just wraps around our center point there. Yeah. All right, so I'm going to put it back at the origin. I'm going to take a snapshot of that so I can finish off this problem here. 0. Right, it's just convenient to have it there. Okay. All right, and let me shrink this down so I can get a nice little picture going on here. Like, yeah, that's fine. Okay, take another snapshot, smile for the camera, and let's pull this one in here now. All right, I did that because the other point that we need to put on here, so first of all, it said that this was, I do believe, point A. The center point is C. Let me make sure. And then B is some other point. They don't give us the coordinates of, but it makes a right angle with C. And I can do that pretty easily by just doing this. I'm going to connect A to C like so. And it's basically, if you think of perpendicular lines in the coordinate plane, their slopes are negative reciprocal. So this basically goes up 10.099 and goes right 1. I'll do the same thing, but I'll just go down, and it should be over here someplace. So someplace like right about there. Okay, and if I connect these, there's my point B, and what the question is asking us is, hey, what is the length from A to B there? And here's my right triangle yet again, and we have the two radius lengths, which are the sides of the right angle, which is the square root of 103, the square root of 103, and then we would just use the Pythagorean theorem again in order to find the length of AB here. Okay, so putting these things into the Pythagorean theorem this time, I got the square root of 103 squared plus the square root of 103 squared is equal to c squared. I don't know if this is related to why some people chose, like a quarter of people chose answer choice B. I don't know at all, like, because I've got square roots 103 in here, but some people thought that it was 2 times the square root of 102. No, that is not the case. Anyway, let's square and cancel out these square roots here. This is 103 plus another 103 is equal to c squared. Add those together, you get 206 is equal to c squared, which means that c, the length of AB, is equal to the square root of 206, which is answer choice A for sure. All right, let me just extend this just a little bit, and that is with something that's called the distance formula. So I didn't need to necessarily have the picture with technology with Desmos. I could have done it 100% by hand if I knew a couple of formulas, one of which is the distance formula. Distance formula, once again, is going to look like the Pythagorean theorem. It's also going to look like the equation of the circle. But basically what you do is you take the square root of both sides. Here's what this is going to look like. If I draw myself a coordinate plane here, and I'm going to put point A with ordered pair x sub 1 comma y sub 1, and then I put point B over here at x sub 2 comma y sub 2, and then I string myself a segment straight between these two things. There we go. If I wanted to find the length of AB, it looks like the square root of, I take the difference of the two x's, so x sub 2 minus x sub 1 squared plus, and now take the difference of the two y's, y sub 2 minus y sub 1 squared. And the reason why this is basically still the Pythagorean theorem, if I drop this segment straight down, and I come straight across here, this is like our A being squared here, and this is like our B, with our B being squared over here, and then you just have your hypotenuse C, and you've taken the square root of that in order to get the length of that hypotenuse, right? Okay, so using that little formula, we have, let's see, I'm going to list out the 2 points that we're finding the distance between. So one of them is h comma k. We'll think of this as our x sub 1 comma y sub 1, right? And then our point A was given to us as h plus 1 comma k plus the square root of 102. And we'll think of this as our x sub 2, y sub 2, okay? And then just plug these things into the distance formula, as I just showed you. Should be the square root of, I'm going to take the difference of the two x's as h plus 1 minus h. Again, this is the the x sub 2 minus x sub 1 there, and then I got to square it, plus, and now do the exact same thing with the y values, so k plus the square root of 102 minus the k, and that thing gets squared. And how convenient is this? Watch this. These h's cancel out, and these k's also cancel out. And then I'm left with the square root of 1 squared plus the square root of 102 squared, and that, my friends, looks really similar to what we did way up here, this first picture here, right? It was this. It's just like that, it's just that there was a square root that's wrapped around that whole thing. Once again, it's just connecting this idea of the distance formula, the equation of the circle, and the Pythagorean theorem in one nice little package. So this is square root of 1 plus 102, which is the square root of 103, which gives you, of course, the length of the radius, and then you're making yourself a little right triangle. Did I draw a little picture of this right triangle? No, I didn't. I had it on the circle. You would know something like this: square root of 103, square root of 103, and that looks like 10q. Now it's 103, and then you're just finding the length of the hypotenuse between those. So it is possible to do without technology, but of course Desmos does help pave the way, help us visualize what could possibly work to find our solution.